Welcome to this video lecture on the subject optical and microwave engineering. So in this lecture we are going to discuss about microwave T junctions. So microwave passive devices are used inside the microwave measurement instruments. They are used to combine the instruments to create more complex measurement systems. So for example, it can split the waves and combine, filter, attenuate. So these are the purpose of passive component. So for example, we have power dividers and RT junctions, directional couplers, magic T, attenuator and resonator. So we are going to see T junctions in detail. So what are T-junction? These are the microwave passive devices. So it is a T-junction is known as intersection of three waveguides in the form of English alphabet T. So it is in T shape. So there are several types of T-junctions. So in this microwave circuits, a waveguide or coaxial line with three independent ports is commonly referred to as a T-junction. So they are used to connect a branch of the waveguide in series or parallel with the main waveguide. So it splitting and also combining the power in a waveguide system. So there are basic two types, E-plane T, also known as series T, and H-plane T, which is known as shunt T. So we can discuss these two types. So E-plane T, here in this diagram we have a main waveguide. It is port 1, mentioned as port 1 and port 2. And a side arm is attached here. It is known as the E-arm, which is port 3. So here the axis of the side arm is parallel to the electric field of the main waveguide. So it is called as E-plane T. So here the rectangular slot is cut along the broader dimension and third port is attached. It is known as the E-arm. And what is the characteristics of the E-plane T is when the wave are fed into the side arm, which is port 3. Here it splits the wave equally in port 1 and 2 and opposite phase. So same magnitude we get. So both the S parameters are equal but negative sign is used. And also it is known as difference arm because when we give the signal at port 3 it splits the wave, and also if two input waves are fed into 1 and 2, output wave will be opposite in phase and is subtractive, so it is called as the difference arm. The port 3 is called as the difference arm. So we can derive the scattering matrix for E-plane T since S is a 3 cross 3 matrix because there are 3 ports in E-plane T. So we can write 3 cross 3 matrix and apply the properties of E-plane T. So S13 equal to minus S23 and substitute the conditions. So which is S33 equal to 0, since port 3 is perfectly matched to the junction, it means there is no reflection from port 3. And symmetry property we can apply. Here the two parameters are equal, reciprocal. S12 equal to S21 and S13 equal to S31. S23 equal to S32. So substitute all these conditions in this S matrix equation. And by applying the unity property of S matrix, S multiplied by its conjugate equal to identity matrix. So from this we can derive three set of equations. And by solving these three set of equation, we get S11 equal to S22 and substitute this value to get S13 equal to 1 by root 2. And similarly we get three S parameters are equal, S11, S12, S22. So we already derived one value, and similarly S11 becomes 1 by 2. So we substitute these values in S matrix to get the equation of E-plane T. So next we shall discuss the H-plane T. So here what we do is it is similar to E-plane T, but it is known as shunt T because by cutting the rectangular slot along the width of the main waveguide and attaching the another waveguide in the side arm, it is called as H arm. And also H-plane T, in which axis of the side arm is shunting the E field or parallel to the H field. So it is called as shunt T. Here the port 1 and 2 of main waveguide are called as collinear arms and port 3 is the H arm. So what is the characteristic is, if two input waves are given in port 1 and 2, output at port 3 will be in phase and additive. So it is called as the summum. So this is the main difference between E plane and H plane. So we can see this diagram here. The side arm is attached along the width. So in this we have 1 and 2 collinear arms and port 3 is the side arm. So S matrix is it can be derived similarly to the E plane T, but there is only one condition, that is S13 equal to S23. So in E plane T we consider it is an minus S23 because that is the opposite phase. So this is the only difference between these two. And by applying the properties of the S matrix, we can derive three set of equations. And by solving this, we get S13 equal to 1 by root 2. And also another condition is we are obtaining S11 equal to S22. And we substitute these values to get S11 equal to 1 by 2. And similarly S12 equal to minus 1 by 2. So S22 equal to 1 by 2. So we derive the values of S parameters. So we get S matrix of H plane T as S equal to 1 by 2 minus 1 by 2, 1 by root 2. And on the second row minus 1 by 2, 1 by 2, 1 by root 2 and 1 by root 2, 1 by root 2, 0. So from this we can write the equation of H plane T, B equal to S into A. So these are the assessment questions. Why E plane T junction is called as the series T, and the diagonal elements of the S matrix of a resistive T junction. Why third port is summum in H plane T. So the answer is the axis of the side arm is parallel to electric field. So it is called as the series junction, and the diagonal elements are equal to 0. And H plane T, the output wave is in phase and additive, so it is called as the summum. So thank you for listening this lecture.